All right, we're recording. Good morning again, everybody, and advance happy weekend. Hopefully, happy pa rin yung weekend. Although on Monday we will have the first laboratory exercise for the course. Nasulat ko na siya nung isang araw, tas ginawa ko yung answer key kaninang madaling araw. So I think it can be done in less than 3 hours, provided you have the code with you or the program with you. So ngayon, ang gagawin natin, we'll continue on discussing parts of module number 2. I don't think we can finish everything in module number 2. So medyo meron pa tayong ititira na parts ng module 2 on para sa next week. But we'll focus more on building up the interpolating polynomial, and I'll show you a program para pwede niyong gawing basihan or pwede niyong gawing pattern para dun sa program na isusulat nyo for the laboratory exercise on Monday. Just a quick recall, last time we talked about interpolation and approximation. We said interpolation is a specific case of approximation wherein we build up a function that will pass through a given set of data. All right? So ayun yung peculiarity o distinguishing characteristic ng isang interpolant o ng isang pang-interpolate sa given set of data. Yung interpolating polynomial ay yung interpolating function ay isang approximating function na dumaraan eksakto dun sa mga given set of data dun sa inyong problem. All right? And remember, this is in tune with the general idea of mathematics as discovering patterns. Halimbawa, sige nga, just a quick icebreaker para magising tayo. Meron ako ditong numbers, tapos hulaan natin yung pattern, ano? I have 1, 2, 3, I have a blank here, 8 and 13. Tatandaan niyo ba yung mga ganitong exam? Ano nga tawag dito? Quantitative reasoning nga ba? So what is the number in the blank? Ano dapat yung number sa blank? Rensis says 5. Oh, bumabaha ng 5. Fibonacci. Oops. Yun yung problema sa Teams. Kailangan ko palang i-off yung chat box. Okay. There's a lot of you saying 5. Bakit 5? Okay, sige. Abuse the chat button for now. Bakit 5? Parang may nagsabi na kanina na Fibonacci daw, meaning you will sum up. I think you got 5 by summing up the previous terms, right? So for instance, 1 plus 2, you're gonna get 3. Then you get a blank, and then this plus this should be 13. Probably that's how you got the number, right? Pero I'll say that you are wrong. The answer is 4.8, right? Not quite 5, pero 4.8. Ano yung pattern na ginamit ko para ma-generate yung data na yan? Ang ginamit kong pattern ay sila yung mga unang integer function values o sila yung function values ng polynomial na to. Negative x to the fourth over 120 plus 13x cubed over 60 minus 131x squared over 120 plus 173x over 60 minus 1. Pag pinlagin nyo si 1, makukuha nyo si 1. Pinlagin nyo si 2, makukuha nyo si 2. Pinlagin nyo si 3, makukuha nyo ay 3. Pinlagin nyo si 5, makukuha nyo ay 8. Pinlagin nyo si 6, makukuha nyo ay 13. So pag pinlagin mo si 4, makukuha mo si 4.8, right? So, yeah. Pero common ano, I mean, common sa atin, isipin na 5, ano? Kasi ill-posed yung problem or insufficient yung information dun sa problem. Kaya posibleng maraming sagot. Pero at the back of my mind, ito yung ginamit ko na model para makuha yon, right? And this is an example of an points 1, 1, 2, 2, 3, 3, 5, 8, and 6, 13, right? Ito yung kaya ko ma-generate. So we will look at ways on how to build up an interpolating polynomial like this for a given set of data, right? But before that, we will finish the proof of the unisolvence theorem. Remember last time we were trying to prove this theorem. Ang sinasabi ng unisolvence theorem, kapag ka meron kang n plus 1 points, laging may mag-exist na unique interpolating polynomial. And we said we divide the proof into two parts, existence, uniqueness, right? Nagawa na natin yung uniqueness last time by giving a specific example, a specific way of finding the interpolating polynomial, and that's through the Lagrange form. Ang Lagrange form ng interpolating polynomial is given by this formula. The algebraic interpolating polynomial is a polynomial of degree not more than n. Alright? So meron kang n plus 1 points, ang maximum degree na posible para dun sa algebraic interpolating polynomial natin ay n. And the Lagrange form is given by the summation of f of x sub k, which are the function values given in your data set, times the Lagrange basis polynomial. Then we take the summation all over the n plus 1 data points. The kth Lagrange interpolating polynomial is simply the product of x minus x sub I over x sub k minus x sub I going from 1 to n plus 1, provided I not equal to k. Bakit maganda or bakit ito yung ginagamit na polynomial? Kasi ang kagandahan ng Lagrange basis polynomial, kapag pinlog-in ko yung pang j na abscissa on x value dun sa kth Lagrange basis polynomial, ang value niya ay 1 kapag si k ay equal kay j. Tapos siya ay magzi-0 kapag si k ay hindi equal kay j. So basically, the kth Lagrange interpolating polynomial indicates to us whether the subscript of the abscissa matches that of the Lagrange basis polynomial. Kasi nga, pag nag-plug in ako ng mga x sub j's, yung mga data points o yung mga abscissas na given, lagi lamang 1 or 0 yung value ng kth Lagrange polynomial. Nagiging 1 lang siya kapag parehas yung indices ng Lagrange basis at saka ng abscissa. Kung magkaiba, equal siya kay 0. Tapos medyo madaya ito. Bakit siya madaya? Kasi pagka in-expand natin yung Lagrange yung Lagrange form ng interpolating polynomial, tapos pinlog-in ko si x sub j, ganito yung magiging itsura. Right? So si p sub n given before, and then I plug in x sub j, right? So f of x1, f of x2, tapos f of xj, f of xj minus 1, f of xj, f of xj, may typo, dapat ito ay plus 1 sa index, alright? Tapos sabi natin, nagiging equal lamang yung Lagrange basis polynomial sa 1 kapag parehas yung index. So ibig sabihin si f of xj, siya yung may katabing lj of xj, saka lang naging 1 yung value. For all the other abscissas, yung Lagrange basis polynomial ay equal kay 0 kasi si Lj o si Lk ay hindi equal and si j ay hindi equal kay k. That explains why 0 yung coefficients ng ibang function value. So pag nagpa-plug in tayo ng mga abscissas, lahat ng terms doon sa algebraic interpolating polynomial ay magzi-0 except kapag nagmamatch yung index ng Lagrange basis polynomial at nung abscissas, leaving us with the function value of x of j. Parang ang parang ang dali lang, ang napaka-logical nung pagkakagawa ng Lagrange basis polynomial. Naunahan lang tayo ni Lagrange, ano? Yes, Mary? May question ka?
Sir, question po dun sa L sub k of x sub j. Di ba po dito po parang x sub j po yung na-miss natin na x sub I? Hindi po ba siya dapat x sub k, sir? Kasi I is not equal to k po?
Sang part dito sa L sub k dito?
Yes po, sir.
Yeah. Yun nga yung kailangan kong i-correct dito, no? Hold on. LK, okay. Tapos, yes, thank you, Mitzi. Dapat ito ay x sub. So, dapat ang mamimiss natin ay si k. So, dapat ito ay k, 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 k. Yeah. Tama na ba? Yeah. Thank you, Mary. Ito yung dito ako na-stuck nga pala last time, nasabi ko parang may mali dun sa notes. So, thank you for pointing that out, Mary. So you get extra points for that. Paalala mo na lang sa akin sa chat mamaya, So the k yung pang k na Lagrange basis polynomial yung hinahanap ko. So ibig sabihin Hold on. LK. Ito ay pang LK. Si I ay, hindi. Yeah, tama. So, kasi dapat walang subtrahend na equal kay K. Yeah, thank you, Mary. So, that's the correction there. All right. So, this proves the existence of the Lagrange of an algebraic interpolating polynomial. Next question, as promised by the unisolvence theorem, unique ba yung makukuha natin na algebraic interpolating polynomial? So this is the classical proof of uniqueness. Sa 101, tinuruan ko kayo dati or most of you tinuruan ko dati ng pag-prove ng uniqueness. I-assume mo meron dalawa na nakaka-satisfy ng gusto mong property and you want to show eventually that they are or they must be equal to each other. Right? So that's what we'll do. So to prove uniqueness, I assume that there exist two algebraic interpolating polynomials, say P and Q, relative to the set of data points. Remember, pag sinabi nating algebraic interpolating polynomials, by the way, I defined it in the modules, kapag ka meron kang n plus 1 data points, lagi kang ang degree ng mga algebraic interpolating polynomial ay hindi lalagpas ng n. It is at most n. So that means by saying that the P and Q are two algebraic interpolating polynomials relative to a set of n plus 1 data points, ang degree ni P at saka ni Q ay hindi lalampas ng n. Right? So with those information, I will construct the polynomial R of x, and I will define R of x to be the difference of P of x minus Q of x for all x in the set of real numbers. And then what can we say about the degree of R? So ayan si R, P of x minus Q of x. Ano yung degree ni R? Anyone? What's the degree of R? Come on, guys. All right, thank you, Jace and Christian. Elgin and Victor, medyo edit yung answers nyo. Ano? Si P ay degree no more than n. Si Q ay degree no more than n. So ibig sabihin si R, ang degree niya rin no more than n. Right? We are subtracting two polynomials of degree na hindi lalampas kay n. Hindi natin alam kung sila ay eksaktong n, pero sure ako, ito ay less than or equal to n. This is less than or equal to n. So the difference of two polynomials of degree less than or equal to n will also be less than or equal to n. So that's the only thing we are sure of. The degree of R is no more than n. Hindi siya lalampas ng n, right? So hindi siya lalampas ng n. Tapos tingnan natin. Kapag kay R, pinlog-in ko yung bawat isa dun sa mga abscisas. I plug in into R each of the x of j's, j going from 1 to n plus 1. Makukuha ko ay pxj minus q of xj. Saan equal yung r of xj na yan? Can you simplify this difference? Saan equal ang r of xj for any j from 1 to n plus 1? Yes, Ela and Kiran, Bernadette, and Ray are all correct. Equal yan kay 0. Kasi yung P of xj, property nga, si P ay algebraic interpolating polynomial, so yung function value niya ay equal sa f of xj, right? Given data. Kasi nga nagpa-pass through si P dun sa given data points. Likewise, ganun din si Q. Kasi sabi natin, algebraic interpolating polynomial din siya, so their difference is equal to 0. So what have we found here? Si R of xj, si R of x ay nagsi-0 sa bawat isa sa mga x sub j's. Ilan yung mga x sub j's? We do have n plus 1 of them. So that means, in summary, we have a polynomial R of degree not more than n, pero meron siyang n plus 1 distinct roots. N plus 1 distinct roots. Right? Tandaan nyo bang fundamental theorem of algebra? Ito, nakasulat siya dyan. Or kinalimutan nyo na yan after nyo mag-math. Hindi na pala kayo nag-math 17, ano? So sa junior, sa senior high nyo na siguro to nakita. Can anyone recite for me the fundamental theorem of algebra? Oh, yes, Prince. Tanda mo pa ba? You can shoot. Yeah, you can use the chat box or you can unmute yourself. Go ahead, Prince.
Yung polynomial with degree n po ata, mayroon din po siyang n roots po.
Aha. Talagang pag sumasagot kayo, may yata or may question mark, ano. Pero yeah, essentially that's correct. If you have a polynomial of degree of degree n, meron siyang at most n roots or at most n distinct roots. Just to be safe about it. A degree n polynomial will have at most n distinct roots. Pero what do we have here? We have a degree n, a polynomial r of degree at most n. Pero meron siyang n plus 1 distinct roots. Sumobra yung roots kesa dun sa degree. And then the fundamental theorem only has one implication for that. Ang implication niya, si R ay yung zero polynomial. Right? Because sa polynomial, hindi posibleng mas malaki yung number of distinct roots kesa sa kanyang degree unless siya yung polynomial na zero everywhere. Right? And that's what we get. So that means R of x is identically zero for any x. Pero paano nga define si R? Si R is defined to be P minus Q. So that means P minus Q is equal to zero for all of the x's in the domain. So that means P of x is equal to Q of x. So nag-start tayo sa dalawang algebraic interpolating polynomials P and Q, but essentially we have shown through the fundamental theorem of algebra that P and Q are identical. And that ends the proof of uniqueness. All right. That clear? Any questions? Okay, I hope the proof is making sense. Ano? So that's it. That's the unisolvence theorem, which gives us a nice property na kahit ano palang data points yung ibigay sa atin, laging merong algebraic interpolating polynomial. We can always find a polynomial of degree not more than n. Alright, kung meron kang n plus 1 data points, lagi tayong may makikitang polynomial na degree hindi lalampas ng n na magpapass through dun sa lahat ng given points. Kahit ano pa yung itsura ng mga data points mo, right? And that algebraic interpolating polynomial is unique. Kahit ano pa yung gamitin yung form. Actually, there's a Lagrange form, there's a Newton form for the algebraic interpolating polynomial. Essentially, when you simplify what you get from those two algorithms, they will be equal to each other. Okay, which is one advantage of using the algebraic interpolating polynomial. Sure tayo na laging may algebraic interpolating polynomial, tapos sure tayo na unique siya. And not more than that, what you call this, advantage use ng paggamit ng polynomials. Kasi number one, ang polynomials, they are very good for computer implementation. Kasi madaling mag-evaluate ng polynomial using computers because ang involved lang naman sa pag-evaluate ng polynomials ay ang basic arithmetic operations, right? So if you want to evaluate any polynomial, 4 operations lang yung kailangan mong gamitin for the computer and then you'll get the answer. Hindi katulad ng sine, ng e to the x na kailangan ng paano ba nag-work ang calculators pagko-compute ng transcendental. Gagamitin nila yung Taylor series expansion, which is much more expensive. And also, the derivative and the integral of polynomials are also polynomials. So, yung mga further analysis na gagawin nyo dun sa algebraic interpolating polynomial nyo ay mas madali. Kasi napaka-well-behaved ng polynomials. Yun nga, derivative niya ay polynomial pa rin, integral niya ay polynomial pa rin. So mapasarili niya, derivative niya or integral niya, ang daling evaluate using computers. So that's why many people use their interpolating function. Because ang sinasabi lang naman natin dito, unique yung algebraic interpolating polynomial, but there could be other forms of interpolating functions. Merong rational interpolating functions, merong trigonometric interpolating functions, pero they do have their own advantages and disadvantages. Magpo-focus tayo sa polynomials kasi sila yung pinakasimple. All right. Now, as I've mentioned, there are lots of forms for the algebraic interpolating polynomial. Minsan dinidiscuss siya sa numerical analysis bawat isa, pero I'll just discuss one, which is the Lagrange form. Kasi nga pare-pares lang naman sila. So what's the point of studying everything? But each of the forms will have their own advantages. Pero for me, parang madaling intindihan itong Lagrange form. So I'll just settle for the Lagrange form or discussing the Lagrange form. Because essentially, ito yung ginamit natin dun sa proof of uniqueness. Right? So the Lagrange form of the algebraic interpolating polynomial P sub n relative to n plus 1 given data points is given by this summation. And again, we'll see our Lagrange basis polynomials over here. So sana na ano yun na envision nyo na kung paano ko gagawin yung program para dito sa Lagrange form. Right? Now, remark 2.1 is just saying other forms for P sub n and giving you some additional materials kung saan nyo makikita yung Newton's form. But we'll try to skip that, right? Okay. Let's just look at the examples right away. Okay. 9 natin. Find the interpolating polynomials for the point 1,1 or for the points 1,1, 2,4, and 3,9. Well, I guess if you're just looking for if you're just looking at the data, you can say right away, sir, ang dali niyan. Ang sagot dyan ay x squared lang. Right? F of P sub n of x. What is n? Ang n plus 1, meron tayong tatlong data points. So ang n natin ay 2. So P sub 2 of x. Pwede nyo hulaan lang. X squared yung sagot. And without even using the Lagrange form, I know that what I should get by implementing the Lagrange form is x squared. Because x squared is of degree no greater than 3, right? Sorry, no greater than 2. Kasi meron akong 3 data points. So degree at most 2 dapat yung algebraic interpolating polynomial. And x squared will pass through these 3 given points. So by the unisolvence theorem, I know that x squared is the only algebraic interpolating polynomial that I can get from this data point. All right? Madaling hulaan. Pero how did we come up with x squared? Pwedeng mano-mano kasi tatatlo lang naman yung data, no? Para makuha si P sub 2, first function value. Function value at 1, kinuha ko to. Ito yung f of x sub 1. Tapos ito yung Lagrange basis polynomial, L sub 1 of x. All right? So ibig sabihin, meron akong x minus x2. So x minus x2 all over 1, which is the first subsisa, minus 2, first subsisa, minus 3. Alright? Siyempre, bawal akong magka-1 dito sa subtrahend kasi magkakaroon ako ng 1 minus 1. And then f of x2, second function value, we get 4. And then Lagrange basis polynomial L sub 2. Kailangan ko yung x minus x sub j, pero yung j hindi equal kay 2. Kaya meron lang akong x minus 1 at saka x minus 3. Wala akong x minus 2 kasi yung x kasi si 2 siya yung pangalawang abscissa. Sa L2, wala dapat x minus x2. Right? Tapos, pag meron ka ng x minus 1, x minus 3, na-determine mo na yung numerator, madali na yung denominator kasi kakopyahin mo lang yung subtrahends, yung minuend, papalitan mo lamang nung pangalawang abscissa. Right? Tapos, f of x3, pangatlong function value, times the third Lagrange basis polynomial L3. Sa L3, dapat meron kang x minus x1 at saka x minus x2. X minus the first abscissa, x minus the second abscissa. Tapos sa denominator, kopyahin mo lang yung subtrahends. Tapos ang minuend ay yung pangatlong abscissa. Alright? And then when you simplify this expression out, you're gonna get x squared. Alright? Is that good? Mas nagbe-make sense ano pag meron kang specific example? Alright. So, ganun yung pagko-construct ng Lagrange-based polynomial. Kaya sabi ko nga, ingenious yung pagkakagawa ng Lagrange form. Naunahan lang tayo ni Lagrange para i-define itong interpolating polynomial na ito. No? Okay. Let's try adding an additional point. Ano? So, example 2.2. 4 na points na yung gagamitin ko. 1, 1, 2, 4, 3, 9, 4, 16. But again, you can You can make hula. You can make hula. So, konyo. Pwede kayong manghula. Ano yung Lagrange basis polynomial? So, how many points do we have? We have 1, 2, 3, 4 points. So, ibig sabihin dito, ang n ay equal kay 3 kasi meron tayong 4 points which is n plus 1. So, n is equal to 3. So, I'm looking for p sub 3 of x. The algebraic interpolating polynomial of degree na hindi tataas kay 3. So, at most 3 yung kanyang degree. Now, manghula ko, 1, 1, 2, 4, 3, 9, 4, 16. It seems it is still x squared, right? And x squared is a fine candidate because the degree of x squared is 2, which is no greater than 3. So, posibleng siya yung AIP, all right? Tapos, itong si x squared, dadaan siya sa lahat ng 4 na points na yan. So, therefore, by the unisolvence theorem, I should get x squared for my p sub 3. Alright? So, ganun yung idea rito. At nakakita na naman ako ng typo. So, this should be 1, 2, 3, 4. So, ito ay dapat 3. Although, true naman yung statement, pero dapat 3, ano? The degree is no greater than 3. Okay. So, expand mo ulit. Lagrange form. Kunin mo yung mga function values. F of x1, f of x2, f of x3, f of x4. Tapos, multiplyan lang natin siya ng Lagrange basis polynomial. Meron tayo ngayong 4 na points, so bawat Lagrange basis polynomial ay magiging degree 3. Alright? So, ito yung L1. Alright? So, wala tayong x minus 1 na makikita kasi nasa L1 tayo. So, kaya meron siyang minus 2, minus 3, minus 4. Tapos, meron kang mga binago dun sa denominator para makuha yung constant denominators. Then si 4, mamumultiply siya ng L sub 2 of x. So dapat wala tayong makikita na factor na merong x minus x2. The second abscissa is 2. So dapat walang x minus 2 sa numerator. Hence, you only have x minus 1, x minus 3, and x minus 4. Tapos, copy the subtrahends. Tapos, replace the minuends by x2. You get the Lagrange L2, the Lagrange basis polynomial L2. And the same process will go on until the fourth term. All right? Tapos, pag sinimplify nyo yan, kahit bawat isa dyan, ito ay degree 3, ito ay degree 3, ito ay degree 3, ito ay degree 3, luckily, nag-cancel yung mga x cube. Ang matitira na lamang talaga ay si x squared. As expected. Ano? So, parang redundant yung dinagdag natin na information, yung 4, 16. Kasi nga, nagpa-follow pa rin ng quadratic pattern yung ating points. Sir, ano kaya mangyayari kapag binawasan ko naman? So, imbes na 3, mula dun sa 3 original, gawin ko na lang siyang 2. 1, 1, and 2, 4. Right? So, dito, ang hinahanap natin ay anong AIP? Ang hinahanap nating algebraic interpolating polynomial ay degree no greater than 1. Right? Kasi meron kang 2 points. So, ang n plus 1 natin ay 2. So, n is equal to 1. So, the AIP we're interested in is no more than degree 1. So, ibig sabihin, at most linear lamang yung AIP natin dito. 1, 1, and 2, 4. So, x squared will not be a good candidate. Actually, it should not be a candidate at all kasi ang degree ni x squared ay 2. Lampas siya dun sa degree na hinahanap natin para dun sa AIP. So, here, gagamitin ko lang yung Lagrange formula and I will get the linear function 3x minus 2. And true enough, when you plug in x equals 1, you get 1. If you plug in x equals 2, you get 4. So that would be our AIP for this problem. So you cannot say that, sir, parang mali yung algebra, mali yung unisolvence theorem kasi si x squared magpa-pass through rin naman siya dun sa given data points. Si 3x minus 2 rin pala dadaan dun sa data point. So why does this case not belie the unisolvence theorem? Bakit hindi ko na-violate yung unisolvence theorem? Kahit na pareha si x squared at saka si 3x minus 2 daraan dun sa given data points. Yes, Nicolate? Nicolate ba? Tama ba?
Opo, sir. Dahil po
Right.
dun
Yes.
sir, sa condition na dapat yung degree ay no more than n.
Okay, thank you. That's perfect. Kasi nga, sinasabi ng algebraic interpolating polynomial, by definition, unique daw siya. Ang AIP, dinefine natin na ang degree niya ay hindi lalampas dun sa number of points minus 1. Right? Kung meron kang n data points, hindi siya lalampas dapat ng degree n. Alright, thank you. That's perfect. Right? Sige, punta natin yung mas challenging. Balikan natin yung epidemic model natin from last time. I said, meron tayong table of data sa table 2.1 yata yon na nagpapakita ng number of infected individuals due to the disease. Scroll ko lang pataas. At this particular days. Day 0, wala pang infected. Day 10, may 8 infected. Day 25, meron ng 4,000 plus, and so on, all the way up to day 357. Now, one possible question that you might ask is, alimbawa, gusto ng boss nyo or gusto ng secretary ng DOH, which reminds me, wala pa tayong secretary ng DOH, ano? Alimbawa, gusto niya ay weekly data, ano? So, how do we come up with a model? So, sana, function P, kung saan magpa-plug in lang ako ng 7, 14, 21, and so on, para makuha ko yung given data. Para makuha ko yung number of Kaya lang problema, wala nga tayong function. So the first thing that we'll need to do is to find a model. At suppose ang gusto kong model ay interpolating polynomial. So we'll be looking for a polynomial that will pass through this 5 points. So what's the degree of that polynomial? Sige nga. Kung gagawa ko ng AIP para sa data na to, anong degree yung polynomial na magagamit ko? Makukuha ko? Okay, thank you, Elgin. That's correct. At ano na kayo ngayon, particular na kayong sumagot. The degree is at most 4. Alam niyo na kasi na posibleng mas mababa kasi baka may mga ma-cancel na terms, right? So thank you, Trisha, Neil, Rensis, Donnie, and Dino. Right. So dahil mahirap na tong imano-mano, malalaki na yung mga numbers, ano, hindi katulad ng data ko kanina na napakasimple. Gumamit tayo ng program para dito. So let me share my MATLAB program. Share ko na yung buong screen. Okay. So I hope you guys can see my my screen. Kita niyo na ba yung MATLAB code? Kasi hindi ko pa siya nakikita. How about you guys?
Wala pa po, sir.
All right, hold on. Yun nga lang yung ayoko kay Teams. Ano? Party niya sa screen sharing. Let me try again. Okay, so I hope you can see it now. Okay ba yung size ng font? Gusto ko kasi maliit lang yung font sa computer ko. So, pero pag nagda-demo, dapat malaki. All right, so thank you. So this is a sample code that I wrote for the algebraic interpolating polynomial. Right? So let's go through it one by one. But again, you're not required to use MATLAB. It's just that MATLAB is my choice of programming language kasi mas intuitive siya for me. At saka sayang yung subscription ng UP kung hindi natin gagamitin at i-harness yung power ng MATLAB. Ano? So you can base or you can pattern your program for the laboratory exercise on Monday using this program. Right? Okay, so I'll go through it one by one kasi nga baka bago pa kayo rin masanay kayo. Sabihin ko kung ano yung ginagawa ng bawat line, right? So, when your line, so we usually use lines for MATLAB. So one instruction per line. Actually, pwedeng more than one, separate nyo lang by colons or by semicolons. But anyway, it's a good practice na one instruction lang by line para mas madaling basahin at i-debug. When a line is preceded by a question, by a percent sign, yung mga, laging, ibig sabihin nun ay comment lamang yung after ng percent sign. So MATLAB will ignore the string of characters that goes after the percent symbol. So usually ginagamit yung comments para mas madaling mabasa yung code, para explain para saan ba yung bawat isang part ng code, right? Line 2 is clear. It will just say, it will just ask MATLAB to clear the memory. Kasi pag nag-run ka ng isang MATLAB code, pag hindi mo kinlear, yung mga values ng variables na ginamit in a previous run is still in the memory. Tapos pag may bago ka ng program na ni-run, tapos same variable yung ginamit mo as the variable from the previous run, meron na siyang value na nakatago. So para hindi nyo maggamit yung values for the same variable mula dun sa previous session, I suggest you use clear. Pero kung intentionally gusto nyo gamitan yung previous results ng inyong computations, huwag nyo lagyan ng clear. Ano? So ang gagawin ni clear, buburahin niya lahat ng variables dun sa memory. Okay? Next is close all. Close all is just for MATLAB to close the all figure windows. Pag nag-generate ka ng figure, nag-run ka ng maraming codes, posibleng patong-patong na yung mga windows ng figures. So close all will just close everything, close all figures. You know? Then line number 5, this is important, seams X. Now the seams command will simply tell MATLAB yung mga variables after sila ay treated to be symbolic variables. Alright? Hindi siya data holder. Hindi lamang siya label para sa isang variable. So ibig sabihin si X, hindi yan maglalaman ng isang number or isang string ng text. Si X dapat ay symbolic variable. Right? It will be our variable for our interpolating polynomial. So lahat lamang ng X ititreat ni MATLAB to be symbolic variable. Right? Hindi niya papakalaman yan. Hindi niya hanapan ng ano ang value ni X. Meron kang variable X pero wala kang define na value. Kasi alam niya na si X ay symbolic. Right? That's the symbolic variable or that's the indeterminate that we'll be using. Right? So ibig sabihin yung function na makukuha ko rito ay function of the symbolic character X. Alright? And then, kailangan nating initialize yung ating data para dun sa ating interpolating polynomial, and that's what lines 8 and 9 does. All right? So, uncomment ko lang to. Itong T at D ng line 11 and 12, ito yung ginamit ko para dun sa example ko kanina na akala nyo Fibonacci, hindi naman pala, no? So, burahin ko na siya. So, I stored in a vector T yung day numbers doon sa table 2.1. So, di ba, given yung number of infections sa day 0, day 10, day 25, day 50, and day 100. So, nilagay ko lang yung mga abscissas dun sa vector T. Tapos, I made another vector, pero this time, ang laman naman ni vector D ay yung mga number of infected individuals. So, the vector D in my code will contain the function values. So, ibig sabihin, yung first component ni D ay function value ng first component ni T. The fifth entry in D is the function value of the fifth entry in T. So ibig sabihin, ang hinanap ko, P of 100 dapat ay 357, P of 50 dapat ay 20,677, and so on. So dapat nagmamatch yung components noong abscissas T at saka function value vector D. Alright? All good so far? So mag-initialize lang ako. So pag nabago yung data, nagagawan ko ng interpolating polynomial, edi i-edit ko lang yung lines 8 and 9. Alright? Yung T para sa abscissas, yung D para dun sa function values. Alright? And then, nakadepende yung karamihan ng gagawin natin sa for loop doon sa ilang points yung given. So, kailangan ipa-compute natin kay MATLAB ilan yung data points na given. Alright? So, to count that, ang ginagamit ko ay yung size command. Count how many data we have and put that number as num points. Yung num PTS, siya yung variable para sa dami ng data points. Alright? Now, how do I count the number of data points? Kukunin ko yung size of T. The thing about MATLAB is that it is designed to work with matrices and vectors. Kaya MATLAB yung pangalan niya. Alright? So, ang pangalan niya ay MATLAB Matrix Laboratory. So, tinitreat niya by default yung mga bagay-bagay as vectors or matrices. Right? So, pag pinakuha mo yung size ng isang variable, sasabihin niya ano yung dimension niya as a matrix. Alright? So, here, if you look at T, punta natin si T. Oops, matagal nga pala itong mag-load. Pero kung titingnan natin si T, hindi pa pala siya gumagana. Okay, there you go. Kung titingnan natin si T ay kay MATLAB kapag ka sa vector separated by commas, ibig sabihin yan ay isang row lang tapos different columns. Ang nangyayari lamang ay pag gusto mo nang pumunta sa susunod na row, ay semicolon yung gagamitin mo. So MATLAB will think of T to be a 1, 2, 3, 4, 5, a 1 by 5 vector. Right? Kasi separated by commas, meron kang 5 numbers, so meron kang 5 columns. Pag nagkama ka kasi, that's another column. Para magkaroon ng bagong row, dapat semicolon yung ipapang separate mo dun sa dalawang rows. So it's a 1 by 5 vector. So if I use the command size, tapos ang sinabi ko lang kay MATLAB, i-compute mo yung size of T, ang ibibigay niya sa akin ay 1, 5. Kasi siya ay 1 row and 5 columns. Dimension niya sa matrix. Pag ang gusto ko lamang ay bilangin yung number of columns, dapat lalagyan ko ng 2 para ibigay niya yung second component, size ng second component. So the second component ay 5. So kaya yung num points nito, dapat ibibigay niya sa akin ay 5. Alright? And then for graphing purposes, I want to get the interpolatory interval. So yung interpolatory interval ay dinefine ko lamang to be the vector containing as first component the minimum value of T hanggang maximum value of T. Right? So pagka nag-grant to, first component ng interp-int ay yung pinakamaliit na value ni T, which is 0. Tapos pinakamalaki 100. So ibig sabihin ang interpolatory interval ko ay from 0 to 100. Alright? So lahat to ay preliminary steps pa lamang. Okay, now let's move on. Oops. Paano ko to ngayon i-off? Kasi hindi ko ma-move yung... Hold on, paano ko to i-off? Okay, no. There you go. Okay, now let's move on to the main gist of the program, yung pagko-compute na yung AIP. Now remember, yung algebraic interpolating polynomial in Lagrange form is equal to this. Tagal nga lang no, ng transition pag nag-on ako ng annotation. No? So remember the Lagrange interpolating polynomial is summation ng f of x k Lagrange basis polynomial of x. All right? As I goes from 1, a goes from 1 to n plus 1. Yan yung formula ng Lagrange. All right? So essentially, si P, which is this guy, right? Si P sub n of x ay summation. Kaya, di ba, pagka magko-compute tayo ng summation using a for loop, kailangan i-initialize muna natin na 0 siya. Right? Kaya meron kang P equals 0 para sa start 0 yung value niya. Right? And then we will be iterating on the summation. Right? Kaya naka for loop yung pagkuha ng sum. That's the outer for loop here. And then k goes from 1 to n plus 1, but n plus 1 is the number of points. That's why here I have k equals 1 colon ng points. Yung columns, sabi niya lang 1, 2, the number of points. Tapos, hindi lamang summation yung meron. Kasi dito, kailangan ko sa bawat term doon sa summation, yung Lagrange basis polynomial L sub k. Pero remember, ang itsura ni L sub k, ito ay product ng x minus xj over xk minus xj, provided that j is not equal to k. So yung Lagrange basis polynomial naman ay isang product. And if I will write a product using a for loop, kailangan mag-initialize naman ako ng value na 1. Kasi nga paulit-ulit ako mag-multiply, so yung unang value dapat ni LK ay equal kay 1. Kasi nga product yung gagawin ko. Alright? Now, the inner for loop here, lines 20 to 24, will compute the Lagrange basis polynomial. Alright? So again, I'll start from 1 to... this could have been num points. Kasi na-compute ko na nga pala siya kanina. 1 to num points. Tapos magpa-product tayo. Pero magpa-product lang tayo kapag si K ay hindi equal kay J. Kaya lang dito ay pala yung ginamit ko na pang-iterate. So if I is not equal to K, yung previous value ng Lagrange basis polynomial natin na L sub K ay mamumultiply neto. X minus X sub I over X sub K minus X sub I. Remember, we stored the abscissas in the vector T. Okay? Okay pa ba kayo dyan? Or too much info na? Pero just bear with me. Daanan natin yung buong code kasi kailangan nyo to para sa exercise on Monday. Ano? All right? Everything's good? Any questions so far? Or gusto nyo talagang tagalan yung pagsagot para may time kayo na mag-screenshot tapos itatype nyo na lang to kay MATLAB para sa first exercise, ano? But I hope if you do that, you understand what each line of this code does, ano? All right, and then mako-compute ko na yung pang K na Lagrange basis polynomial. So para dun sa pang K na iteration, previous value ni P plus function value at X sub K times the kth Lagrange polynomial. I-add ko lang siya sa previous P and I'll get P. All right? So that will do it. That would be your Lagrange basis polynomial. That will be your algebraic interpolating polynomial. Now, how do we display the answers? Right? So post-processing na tayo. Now, dito si P, magkakaroon na tayo dyan ng polynomial. Then I will ask MATLAB to simplify it for us. Kasi baka baka hindi niya i-simplify. So naka-nested pa yung products. So in line 31, I will just replace P by the simplified form of P. Yung simplify command kay MATLAB, isi-simplify niya yung polynomial. Okay? Tapos display command, i-display lang ni MATLAB itong string na to. Pagka string yung or text yung gusto niyo ipa-display, lagi siyang naka-enclose sa single quotes. Alright? So, i-display niya lang yung the AIP relative to the data points is, tapos pretty P. Yung pretty, isulat niya lang as much as possible ng maganda yung polynomial P. Alright? Itatry niyang isulat to in our native or native math language. Makita niyo mamaya kung ano yung itsura ng pretty P. Ano? Tapos or, pwede ko siyang i-display in decimal points. So meron akong P, ko lang lahat ng multiplication, yun yung gagawin ng expand. Kasi si P ay naka-Horner's form. Ibig sabihin, naka-nested multiplication form siya. Pag kinol nyo yung command na expand, i-carry out ni MATLAB lahat ng multiplication para siya ay term by term na yung itsura. Right? Tapos kaya lang, itong expand P, symbolic pa rin yan. So itatry ni MATLAB na ibigay. So para makita ko yung decimal representation, yung floating point representation ng mga numbers, gagamitin ko yung VPA. Pag VPA of expand P, bibigay niya lang si expansion of P in decimal form. Alright? Hindi na fractional. Gusto ko ay 4 significant digits, kaya 4 yung nakalagay dyan. Alright? Tapos i-display niya lang. So let's see. Let's try to run it first. I-comment ko muna itong mga hindi pa natin kailangan. Okay, lagyan ko siya ng percent symbol. And then you can just click this run button dun sa editor tab or just press F. The program will run and here you go. Ito yung output niya sa command window. So the AIP relative to the data points is, ito yung output ng pretty. Alright? Sabi nito, x times negative 150,469 x cubed plus 10,186,615 x squared plus this guy x minus this guy all over this number. So ito yung ating algebraic polynomial relative to that given set of data. All right. ito yung result ng pretty. Pero remember, I also asked MATLAB to display it in decimal form, yung may VPA. VPA stands for the variable precision arithmetic. So VPA, expand, ito yung binigay niya in decimal representation. Alright? Kasi meron kang coefficients dyan, i-divide mo by 67 by this big number, ito lang yung matitira. So ito yung expansion niya up to 4 significant digits. Dun sa exercise, meron ako sa inyong ipapa-interpolate, tapos ipapasulat ko yung degree, ano nga ba yun? I think it would be a degree 8 interpolating polynomial. Tapos ipapa-display ko siya ng 4 significant digits. So kailangan naka-scientific notation siya na 4 yung significant digits na ginagamit. Right? Just like this one. So the command for that is easy. Nandito na siya sa code natin. Line 35, display VPA expand P of 4. Right? Pero usually, kapag given sa atin yung mga numbers, symbolic expressions, it's not easy to interpret them, right? Kaya minsan mas okay na meron kang graph. Oh, by the way, kay MATLAB, kapag naglagay kayo ng semicolon at the end of every instruction or every line, ibig sabihin isusuppress ni MATLAB yung output. Pag naglagay ka ng semicolon, hindi output ni MATLAB yung sagot dun sa line na yon. Pero kapag walang semicolon, i-display niya yung sagot dun sa line na yon. Kaya maraming posibleng display kapag hindi kayo naglalagay ng semicolon. Hindi ko nilagyan ng semicolon para ma-display yung final answer. Okay? Sorry, medyo nagmamadali na ako kasi medyo overtime na tayo. But I hope it's okay. If you have a class right after this and you need to go, you may leave the meeting now and just look at the recording. Pero if you'll allow me to spend probably eksaktong hanggang 9:30 and you can stay, just stay para matapos natin to. Kung di naman, just go back to the recording later. Okay ba yun? Para lang ready na kayo sa lab extra on Monday, ano? All right. Now, let's go to displaying the graph. Kasi minsan mas marami tayong insights na makukuha mula sa graph kaysa dito sa polynomial. Sabihin mo, ano naman yung, kung nang layman ka, ano naman kung polynomial yan? Anong insights ang makukuha ko mula dyan sa nakuha mong expression na yan? Usually, mas presentable kapag ka-graph yung ipapakita natin. Right, so lines 37 to 46 will create the graph of the interpolating polynomial on top of the given data. Usually, ginagraph ko siya sa ibabaw ng given data para makita na nagpa-pass through talaga yung aking interpolating polynomial dun sa mga points na ginamit ko. Alright? Now, line 38, yung mga figures, lagi niyong simulan sa syntax na figure. Kasi the figure command will create one window para dun sa figure, para dun siya mag-graph. Otherwise, pag marami kang pinapagraph pero hindi ka gumagamit ng figure command, ano lang sila, magiging patong-patong sila sa isang window, sa isang Cartesian plane. So pag ayaw nyo magpatong-patong sa isang Cartesian plane, yung mga figures na generate nyo, bawat isang figure, lagyan nyo ng figure command. Okay? And then fplot is asking MATLAB to plot a symbolic function. All right? Remember, P is a symbolic variable. Kasi nga si P ay may indeterminate x. Polynomial yan na ito yung itsura sa command window. Alright? So, kaya fplot yung gagamitin ko. Fplot kapag ka-symbolic yung inyong ipapaplot. Ipapaplot ko siya over what x values over the interval of interpolation. Remember, I defined interp_int to be the interval starting from the minimum abscissa until the maximum abscissa. Kailangan ko kasi yun sa plot, right? Para ma-automate siya. So, ang gagawin ng line 39, ipa-plot niya si P over 0 to 100. And then, I want to graph on top of the plot of P yung scatter plot ng mga data points para makita ko na dumaraan talaga, para ma-check ko visually na dumaraan talaga yung interpolating polynomial dun sa mga given points. Alright? So, hold on. Lalagyan ko ng hold on para ito ay Alright? Kung gusto mong another window, yung scatter plot, dilagyan mo ng figure instead of a hold on. Alright? And then hold on, then 41. Yung line 41, ito na yung scatter plot. So, ipa-plot niya on the x-axis yung mga components ni vector t, tapos ang gagamitin niyang y component yung components ni d. So ita-plot lamang ni scatter yung mga points na ang x component ay manggagaling kay t, yung y component manggagaling kay d. I use the field command para may kulay, yung dot, para dun sa mga points na gagawin. Pag wala kayong nilagay na field, ano lang, isang circle na walang kulay yung loob ang gagamitan ni MATLAB para i-plot yung data points, right? But I want a field para mas kita yung kanyang behavior, ano? Tapos title, ito lamang yung gusto kong title ng graph ko, alright? Tapos legend, kasi nga meron akong dalawang information dito, di ba? Yung unang graph ay para sa graph ni P. Kaya ang legend, una, ay interpolant P. Right? Para alam ko na yung kulay orange yon, kulay orange ba? Hindi. Yung kulay blue, unang color kasing ginagamit ni MATLAB by blue. So, by default. So, yung kulay blue gagawin niyang interpolant. So, kasi yun yung una kong pinaplot. So, una sa legend, interpolant P. Tapos pangalawa kong pinagraph ay yung mga data points. So pangalawang legend ko, data points. Tapos dahil dito gumamit ako ng latex command. So sabihin ko kay MATLAB, oy, meron ako dyang latex na symbols. So gamitin mo si latex para i-convert into an form. Right? Otherwise, pag hindi kayo naglagay ng interpreter na latex dito sa legend, ko-consider niya lang as text. So hindi niya to gagawing mukhang equation. Right? Tapos X label, ano yung label sa X-axis? Y label, ano yung label sa Y-axis? Kasi ito ay para lang malaki yung font ng legend. Right? Now, you can rerun the program by pressing F5 or pressing the run button here, or pwede kasing patingi-tingi yung pag-i-implement kay MATLAB. Pwede kong i-highlight lahat ng lines na gusto kong ipa-implement kung ayokong ipa-run yung buong program. Kasi kung makikita niyo sa workspace dito sa kanan, computed na yung mga variables, computed na yung polynomial, right? Yung AIP. So, pwede ko na lang gawin dahil nasa variables na, nakasave na yung mga values na nanggaling dun sa previous run natin. Pwede ko na lang i-run tong 38 to 46 without redoing all the calculations again. And if you want to do that, highlight everything that you want to run, right-click, evaluate selection, or simply press F9. Evaluate selection, run siya, and ito yung figure na lumabas. And you will see, oops, hindi ko what happened? Okay, there you go. Oops, lumipat siya ng screen. Yan. Pwede mong i-drag yung legend para mas madali siyang makita. So here we see the 0, 0, ano nga yung sa 10? Kalimutan ko na yung value kay 10, 10, 8. And then here we have 25, 42, 51. We have 50, 20,680, and so on. So we got the polynomial P, yung plot niya, and it indeed passes through all the 5 given data points. Tapos, ano pa yung maganda rito? Pag given sa yung graph, ang dami mong pwedeng masabi. For instance, alam ko na, yung maximum number of infected individuals ay mangyayari dito sa part na to, which is basically somewhere here. Between day 70 and day 80, makukuha natin yung maximum number of infected individuals, which is about 3 times 10 to the 4th power, right? Just be mindful of the y-axis here. Ang scale niya ay 10 to the 4th. So here there would be around 3.5 times 10 to the 4th infected individuals that will happen between day 70 and day 80. And then dun sa after that day, after day say 75, pababa na yung trend doon sa number of infected individuals. So by just looking at the graph, ang dami na nating makukuhang information. All right? And then remember yung hinihingi sa atin ng secretary ng DOH, weekly data, ano? Gagawin ko ngayon, meron na akong interpolating polynomial P. So, i-evaluate lamang si P kay 7, 14, 21, all the way up to what? 98 para makuha ko yung weekly number of infected individuals. Right? And how do I do that? Well, I'll ask MATLAB to do it for us. Okay. Ayun yung nasa lines 50 to 53. Alright? Una, gagawa muna ako ng time interval kung saan ko i-evaluate yung polynomial. So kailangan kong gumawa ng vector na ang laman niya ay lahat ng gusto kong x values kung saan evaluate yung polynomial, right? So I'll use t-eval to call that vector. Ito yung vector na magsisimula kay 7, papunta kay 100, pero ang increment ay 7. So from 7, I'll take steps of 7 units hanggang makarating ako kay 100. Si 100 hindi divisible by 7, so ang gagawin lang nito, mula kay 7, kukunin ko yung mga numbers, skipping by 7, so 7, 14, 21, 28, hanggang bago ako lumampas ng 100. Right? So if you run this, I'll press F9. So ay, naka-colon pala siya kaya hindi ko makikita yung sagot. Pero pag tinanggal mo yung semicolon sa dulo ni t-eval, tingnan niyo yung command window sa ilalim. So pag tinanggal ko yung semicolon, I'll get this. 7, 14, 21, 28, hanggang kay 98. Kasi nga, ito yung mula kay 7, papunta kay 100, skipping by 7. Okay? And then line 51, ito na yung pag-evaluate. Paano mo sasabihin kay MATLAB na i-substitute mo yung mga values na nandun sa vector na t-eval dun sa polynomial, sa interpolating polynomial. So I will call the vector consisting of the computed function values as p-eval. Ito yung itatawag ko dun sa vector na ang laman ay yung mga function values. Tapos ang command para masabi kay MATLAB na mag-substitute ka ay subs. Right? Ang daling tandaan, no? Substitute subs. Tapos first entry kay subs ay kung ano yung polynomial, saan ka magsa-substitute. So kay polynomial p, isa-substitute ko yung mga numbers na nasa loob ni t-eval. Alright? Kaya lang, pag ito yung ni-run natin, sige, i-run ko yan, F9, ang ibibigay niya ay fractional. Kasi by default, symbolic variable kasi si p, so by default, gagawin ni MATLAB ko compute niya symbolically. So halimbawa, function value kay 7 ay ito, negative this guy over this guy. Kasi naka-fraction nga. P of 14 ay itong fraction na to. Kung gusto niyo ay exactong number. Pero kung gusto naman natin ay decimal values, mag-VPA lang uli ako. Pag nag-VPA ako, line 52, naka-symbolic pa rin siya, pero nakaganto na siya. Naka-decimal symbols. Naka-decimal na yung kanyang representation. Kaya lang, hindi ko ito magagamit sa computation kasi kung titingnan nyo sa workspace, si p-eval, symbolic character pa rin. So hindi ako pwedeng mag-add or mag-manipulate kasi hindi to binabasa ni MATLAB as a number. Binabasa niya to as a symbolic expression. Para i-convert siya sa isang number, kukunin natin yung double para ilipat siya sa double precision. Yung symbolic character, gagawin niyang double precision number. So that's what the final line does. P-eval is the double precision representation of the symbolic vector p-eval. Run natin yan, F9. Oops, meron nga palang semicolon. So, hindi i-display ni MATLAB yung sagot. Pero pag tinanggal natin yung semicolon, sorry, too excited. Ilalabas niya to. So, ito, yung value sa day equals 7, which doesn't make sense. Kasi negative, ito pala. Be careful kay MATLAB kasi fina-factor niya yung magnitude. So si p-eval ay 10 to the 4th times etong laman ng vector na yan. Alright? Kung gusto niyo makita yung number na hindi naka-factor yung magnitude, dun sa workspace, double-click niyo lang yung p-eval, yung variable name. Nandito na ako sa workspace. Medyo maliit yung font sa workspace, pero yung nasa right side. Click niyo yung p-eval na pangalan. Lalabas yung parang Excel. Here you go. Para makita natin yung data. Medyo maliit yung font, pero yeah. At 7, meron ka negative 209.68. At day 14, you have 617.35. At Anong day na to? At day 21, you'll have 2.59 times 10 to the 3rd, and so on. Right? At ito yung makita nyo dun sa table na nandun sa example, kung saan tayo tumigil kanina. Alright? So sorry, 5 minutes overtime na ako, so I'll stop here. Then we'll just continue the last few remaining examples in Module 2 on Tuesday. But at least now you have all the tools for the lab exer on Monday. Any questions? Sorry, medyo minadali ko na kasi super overtime na ako. Okay, any questions? Or too much information for one sitting? Medyo siguro too much info. Kasi, tawag kasi nag-discuss na tayo ng theoretical, tapos nag-ano pa tayo, nag-programming pa, right? So, but try to digest it over the weekend, ano? Yeah, kung hindi kayo familiar sa MATLAB, I hope you get the gist of what I did, ano? Or if you don't really like MATLAB, do it on your programming language of choice. Hindi naman kayo nakatali sa MATLAB, ano? So mas ano lang ako, mas gusto ko lang yung MATLAB kasi intuitive siya. So you can use Python, you can use Excel. Kung mabilis ka naman mag-compute by hand, then gawin mo siya by hand, alright? Doesn't matter. So as long as you get to the same answer. Sabi ng Unisolvent's theorem, kahit ano pang programming language ang gamitin mo, pare-parehas tayo dapat na makuhang interpolating polynomial. Alright? Now, I won't share the file with you guys, so bahala na kayong gumamit ng technology para ma-retrieve yung ginawa ko kanina. So you can go back to the recording later and then try to write it line by line. At least para mapilitan kayong magsulat, mag-type line by line. Kasi ang danger, pag binigay ko yung file, iraran nyo na lang siya. At least kung kokopyahin nyo siya mula dun sa recording, maintindihan nyo kung ano yung ginagawa ng bawat isang line. And I will not belittle you if you will doing that kasi nga baka hindi kayo familiar sa MATLAB, tapos ngayon gusto niyo shift to MATLAB. So one thing that you can do for starters ay mamaya or over the weekend, panoorin si recording. Tapos, habang nag-run yung recording, i-type nyo sa MATLAB line by line. Tapos tingnan nyo yung ano yung na-explain ko yung bawat line, saka nyo siya i-type sa MATLAB. Make sure you understand it. Tapos buuin nyo yung program. Tapos, actually, yun lang yung gagawin nyo eh. Magpapalitan nyo lang yung vector t, papalitan nyo lang yung vector d para dun sa lab exer on Monday. Alright? Oh, by the way, the lab exer will be available sa Canvas mamayang 3 p.m. Alright? I-upload ko na siya mamayang 3 p.m. Tapos, ang deadline niya ay 11:59 sa Mondays. You can start doing it, discuss it with your friends, today or over the weekend, kung nag-work kayo over the weekend or Monday morning if you're on the weekends. Tapos, go to your lab classes on Monday, all right? Tapos, kung may questions kayo, may clarifications, doon nyo itanong sa lab instructors nyo, all right? Or in any case, just attend the lab for the first few minutes, baka may announcement yung inyong lab instructor, So attend the lab sessions, ask questions. If you want to leave, just ask permission from your lab instructor. So aside from hindi familiar sa MATLAB but too much information for one sitting, any other questions or concerns? Okay lang yan kung first time niyo lang magma-MATLAB, So makukuha niyo rin yung flow ng MATLAB. Lalo na kung kung ibang programming language yung ginamit niya dati. Pero ang idea kasi ng programming ay dapat yung conversion from one syntax to another should not be difficult. So kaya hindi dependent sa programming language yung 174 and 175. Pero if you'll be taking the course with me, I suggest you study MATLAB. I don't think mahirap yung transition from one programming language to another. It's just a matter of rewriting the syntax. So no more other concerns? So ang wala na guys, thank you all for coming today. So those sa mga nag-recite verbally, makiki-comment dun sa chat box para ma-record ko. Sino nga ba yun? Si Mary at saka si Nicolette. Mary Mitzi. Sige na, type ko na yung pangalan nyo. Sino pa nag-recite? Wala ba? Si Mary lang at saka si Nicolette. Si Prince. Thank you, Prince.
Sir?
Yes.
Sir, may tanong si Elgin.
Go.
Nasa chat po, sir.
Nasa chat. Ang array matrix indices po ba sa MATLAB nag-start sa 1? Yes, Elgin. Yeah. Nag-start sa 1 yung indexing niya. Kay Python ba, saan siya nag-start? Sa 0 ba siya nag-start? Kay MATLAB, laging 1 nag-start yung indexing. Kaya usually yung sa module, sinatranslate ko siya lagi, nag-start kay 1. Yes, Christian.
Sa MATLAB po ba, sir, dun sa for loops, kasama yung last number dun sa interval? Like yung kanina na dinefine from 1 to, ano yun?
1 to num points.
Apo, kasama po yung last number.
Yes, kasama yung number. So if you ask MATLAB to do a for loop from I going from 1 to 10, gagawin niya yung I equals 10. So start siya sa I equals 1 hanggang I equals 10. Kaya ano ba? Kay Python ba? Kasama din yata kay Python, di ba?
Hindi po, sir.
Hindi. Ang weird.
From one less. Opo.
Kaya
Thank you
ayoko
po,
kay
sir.
Python kasi nawi-weirdan ako dun sa kanyang mga conventions. So pag sinabi mo kay MATLAB na do this from 1 to 10, gagawin niya hanggang kay 10. Hindi niya gagawin hanggang kay 9 lang. Ang medyo nababago lang yung increment. Halimbawa, sinulat mo yung 1, colon, 7, colon, halimbawa, 15. Ayan, yung tinype ko sa chat. 1, colon, 7, colon, 15. Gagawa siya ng vector starting from 1 na hindi lalampas ng 15 ang increment ay 7. So, ang laman ng vector na yan ay 1, tapos 1 plus 7 si 8, tapos, magsasakto pala. 8 plus 7 ay 15. Pero kung ginawa kong 1, 7, 14 yan, hanggang kay 8 lang siya. Hindi niya isasama si 15 kasi kulang na yun pag nag-plus 7. Alright? So try to explore MATLAB, ano? And then if you have some difficulties, your lab instructors will be more than happy to help you on Monday. Tapos sige, I'll try to be online then on Monday, though may meeting akong face-to-face sa umaga. Pero kung gusto niyo mag-consult, I'll be at the math building ba? Probably I'll be at the math building sa hapon ng Monday. So if you want to meet, I'll be there. Ano? So sa room 204 siguro ako tatambay. Siguro hanggang 4 or 3 p.m. doon ako magstay. Alright? Any other questions? Or kung gusto niyo ng MATLAB tutorial, pwede tayo magkita on Monday. Alright? Any other questions? None? Okay, thank you for bearing with me. 13 minutes overtime na tayo. So total of 23 minutes overtime. But thank you guys for staying. Thank you for waking up early. Enjoy the weekend. And let's see each other again on Tuesday, right? Wednesday. Bye, everyone.
Bye, sir.